This is Unit 4, Electrical Resistance, Part 2. And what we are going to talk about today are series and parallel circuits. Now, a series circuit is basically a circuit that only has one path for the electrons to flow through. And these are the equations that we're going to be using. And I'm going to make reference to them because I'm going to keep referring back to them when we are taking a look at some of the schematic charts. Alright, this is the symbol for a battery. Here's the long line is a positive, the short line is a negative. And your electrons are going to come out of the negative terminal. And this is a resistor. Okay, this could be anything, almost anything that you would put in, whether it be a light or an appliance, they all have resistance. Okay, so this is a resistor and it goes through there. Alright, through this resistor over here and then back into the battery. Okay, so basically I always think the key into studying electricity when you're talking about schematics is through the current. The current is electrons. Alright, that's a physical thing. So what's happening is that they're coming out of here and they don't like being outside the battery. Alright, so they're going to be rushing through here, and what happens is all of them must go through here. They don't have a choice. That's the only path that they can take. It's the only path they can take. Alright, only path they can take, and then they run back into the battery. Okay, so basically when we talk about that, there is just one loop. Alright, that's what we're talking about. The electrons, when they come out of the battery, they have no choice, alright, but to go through each of the resistors. Alright, so if you have 3 amps, you're going to have 3 amps through each resistor. Now, this is the table that we use. Typically, what you see is like technicians. They like to mark all their information here. And then you'll find that a lot of times engineers, they like to make the table. Okay, I'll be honest, I do a little bit of both, but I fill out both things. But what we're going to concentrate on is really making sure that we can answer all the equations or all the boxes and fill them all in, kind of like a puzzle, to answer all that we can for this circuit. R stands for resistance, I is current, V is voltage, and P is power. Okay, now this is set up very special. It's R times I. Alright, will give you V, and I times V gives you P. A little rhyme there so that you can remember. Alright, so R times I equals V, I times V equals P. Now, when you're looking at resistance, if you take all the resistors that you have in this series and you add them up, you'll get your total resistance. Now, what that basically means is if I were to take those 3 resistors out and I replace them with one single resistor, that's what my total would be. Alright, and then we have the I column. Alright, do you see where we have, alright, this row right here, and we have 2 in the I column, but it's also in the R total column. Basically what this means is this is going to be what's coming out of the battery. So you have 2 amps coming out of the battery here. And that's what's given to you. You have to be given a certain amount of information. If you were in the lab, you would be measuring these things with a multimeter. Alright, so what happens here is this P column, we didn't really talk about that. They really call this a checking column, and where it really comes in handy is when you get into actually more complicated. There are combinations of series and parallel circuits. But we start off by teaching that so that you have the same chart from the very beginning. Alright, I'm going to go to the next slide, and what you're going to see with this PowerPoint, I give you an empty schematic with the chart, and then on the next slide is going to be the answers. Alright, so you can see where everything's coming from. And I'm going to take you through this one, and then you're going to try these. Alright, you have 5 plus 15 plus 30. That will give you 50. So that means if I took these 3 resistors out, I could replace them with the 50 ohm resistor. Alright, you are given that you've got 2 amps. 2 amps coming out of the battery. So if you got 2 amps there, you must have 2 here. There's nowhere else for the electrons to go. 2 amps here and 2 amps here, and then back into the battery. So that's what you'll find, that in series the current is the same throughout. Now to find the voltage, you're going to take 5 times 2 will give you 10. 15 times 2 give you 30. 30 times 2 will give you 60. 50 times 2 will give you 100. Alright, and then you have I times V. But before I go on, let me just point out something to you. You have 100 volts coming out of the battery. As the voltage comes through each resistor, the voltage is used up. They refer to that as a voltage drop. Okay, so right here, this resistor here is going to use up 60 volts. This one is going to use up 30 volts, and this one will use up 10 volts. Now, if you add all those up, if you add 10, 30, and 60, it equals 100. Alright, so when you are checking voltage in series, you should find that when you add up the voltages in the resistors, they should add up to your total voltage. And then the checking column, I times V equals P. 2 times 10 is 20. 2 times 30 is 60. 2 times 60 is 120. Alright, if I add these up, I get 200. 2 times 100 gives you 200. So it checks in both the vertical and the horizontal position. Okay, what I want you to do is I want you to try this one. Alright, and then what I want you to do is on the next slide is the answers. And you can go and you can see how close you are. Alright, series are very simple. I don't think you'll have a whole lot of trouble with that. Alright, and then there's another example. Do the same thing with that. And then there's another example. Do the same thing with that. Alright, and quiz yourself on this. I'm just calling it series quiz, but it's just a little quiz for you. Not that it's going to count or anything. Just do your best. Alright, so that's series. The next type we have is parallel circuits. Now these are just a little bit harder. Not that they're bad, but they're a little bit different. Alright, these are circuits that have multiple paths for electrons to flow. Alright, and let me show you, these are going to be the equations we're going to use, and I'm going to explain those. Alright, this is what a parallel circuit looks like. You've got parallel branches. Alright, so what happens here, the electrons come out, and some are going to go this way. Alright, and some will go that way, some will go that way, and some will go that way. These resistors act almost like a filter, or a gate, if you wish. They only let so many through. Okay? And that's how they behave. Now, these equations, they look really weird. Alright? But they're really not that bad. Okay, what we're going to be doing is we're going to be finding our total. But we're going to take our resistance and we're going to put them in fraction form. Now there is an easier way to do that, but I'll talk about a couple different ways here to manage those. Your current is no longer going to be identical, okay, and your voltage isn't going to add up, okay. You really have to do examples to make these equations make sense to you. All right, you have 4 resistors. They're in parallel with each other. They're 48 ohms each. So you can do it this way. 1 over 48 plus 1 over 48 plus 1 over 48 plus 1 over 48. That, when you add those up, that will give you 4 over 48. Alright? And if you reduce that so that you have a 1 in the numerator, you'll have 1 over 12. And that means you take the denominator number, and this will be 12. Okay, now another way to do this that I like to use, that I was taught, if fractions aren't your thing, is you have a key. If you have a scientific calculator, you should have on your calculator, it's either going to be marked as an x to the -1 key or a 1 over x key. And what I would do is I would hit 48, 1 over x, plus 48, 1 over x, plus 48, 1 over x, plus 48, 1 over x, equals 1 over x one last time, and what I would end up would be 12. Okay, so it works either way. Now another way, just a shortcut if you hadn't picked up on what it was, if they are identical, all right, you know, so they're all 48s, count the number of lines that you have. You have 4, all right, 1, 2, 3, 4. All right, 48 divided by 4 will give you 12. Okay, now I'm going to move to the next slide so you can see some numbers. So this is 12. All right. If you look down here in the bottom, you were given 24 volts. 24 volts are coming out of the battery here. I want to know what the current is. I'm going to take 24 divided by 12. That will give me 2. That means I have 2 amps coming out of the battery. But the problem is that I only have 2 amps total. So that means that the current is going to have to split up. If they're identical, like you have here, they're going to split identically. And that's where you get the 0.5 from. Alright? If you have trouble remembering that, then remember this. In a parallel circuit, voltage is the same in every parallel branch, no matter what the resistance is. Alright, and that's why these are all 24. Okay? Now, going back to the current. If you take your current and you add it up, it should add up to 2. Alright, if it doesn't, you know you have a mistake. Alright, and you can double check here. Make sure everything is right. You had 24. 24 divided by 48, it's going to be 0.5. Alright, and since they're all identical, they're going to be 0.5. Alright, now you're checking. You got 0.5 times 24. Remember, I times V will give you P. So 0.5 times 24 gives you 12. If you take 12 plus 12 plus 12 plus 12, it gives you 48. Alright, and then 2 times 24 will give you 48. That's how you check. So the big thing to remember here is, when you're doing your resistance will always be smaller than your smallest resistor. That's one way to check. And the second thing is your voltage will be the same throughout. That makes it easy for you. Now what I want you to do, there are some parallel circuits here. I want you to do what you did before. I want you to take a look at these, see if you can fill in the chart. So you're going to need paper and pencil. And you're going to try and fill these in. You get stuck, alright, look to see what the answer is. Alright, and then finish filling it out. Then go to the next example and try it again. Alright, you get stuck, check the answers. Alright, so that's it for circuits. Good luck. They actually are a lot of fun. I would go with them like as if it's a puzzle. And if you take that attitude, they're really not that bad. Have a good week.